We've talked a lot about digital asset capture and use, but it's important that we realize that fashion isn't kind of out on a limb here. There's a lot of other industries who've already taken a big bite out of the possibilities of 3D scanning, from engineering and architecture to movie VFX. What does that mean for the pipelines we're building for digitizing fashion? And here to talk to us about that is Michael Raphael, who is president of Direct Dimensions. And I'm going to hand over to him now.
Good morning, good afternoon, good evening, depending on where you are. It's nice to be with you. Thank you very much, Ben, for handing this over. And by the way, that presentation beforehand was a great tee up for what we will be talking about, which is 3D scanning in general, very broadly, including apparel and accessory applications, which I will go into. Let's see, how do I make that work? Okay, here we go. Hopefully this is coming through. I am the president, as mentioned, founder of a company called Direct Dimensions. We started in 1995 in 3D scanning. I used to be in the aerospace manufacturing world, helped develop some technology for these capabilities of solving manufacturing problems, and have since, with Direct Dimensions, expanded our company to provide these services very broadly, and you will get a sense of that, where this all goes and how these tools that have been developed for many industries may be relevant to your workflows and your needs. As mentioned, I helped develop this device that's over my shoulder, this arm device. It's a mechanical arm. It's not robotic. You move it around manually, and it's a digitizer, as you can almost sense from this picture. We use many other tools and have used many tools over the years. This is me back in the day when we first developed this measuring device, using it for these industrial applications for solving manufacturing problems to build very complex shaped aerospace structures and satellite dishes and the like. As I said, I left and we started Direct Dimensions with that device and have since added many more. And we go in all of these directions and across all of these industries with this capability and technology, both as a service where we go out and scan, and you'll see pictures of that. And we also provide the equipment and capabilities to transition that internally to organizations that would like to learn to do this themselves. And then later on this talk, we'll see where we've developed some of our own solutions for sort of specific 3D scanning problems. But clearly there is a wide world of things out there in the physical world that are not in the computer, and many reasons, as we're hearing for these 3 days during this 3D Tech Fest conference, as to why many of these things need to be in the computer, digitized and accurately. As noted, this is some of the many projects that we've done out in the field in many environments. If things are small, they come to us. If it's larger, as you can see here, we go to it. I mentioned we work with today a wide range of scanners. This is many of them, and I actually brought one just to show you, just a little handheld that we use quite frequently for simple projects. Very easy to take out in the field and go scan things for lots of applications across all of these worlds. You know, scanners, and there's many on the screen here. You know, it's like a tool in your toolbox. No one tool does everything that you need to do. So there are a lot of scanners on the market that come from companies all over the world. We use what we consider the best of the best for the work that we do. Things that have the most utility, the most application capability that we're interested in, and you know, things that we would represent and provide to our customers as well when they would like to bring that in-house. Just to give you a sense, again, we're talking about a whole industry of companies and organizations around the world that have adopted scanning for many, different applications. And just engineering and manufacturing, we call it our industrial market, is gigantic. You know, there are many different things that have been designed and developed over the years: airplanes, cars, ground vehicles, power generation, all kinds of things that have been fabricated where they're not in the computer. They were designed and maybe built before computers, and you know, maybe they have blueprints. They're probably wrong. These parts were never designed accurately, and these things need to go into the computer for subsequent design for engineering and manufacturing purposes. Here's just one simple example: a fuselage of an airplane. We go inside, we scan and digitize all of the elements that are exposed. We create the mesh information up at the top, and then on the right, lower right, is ultimately what we create, which is the CAD model. And this is what's needed for doing engineering and manufacturing work on that fuselage. And, you know, as I mentioned, ground vehicles, many widgets, things that we see that come to us or we go out in the field and do. Sometimes we don't even know what they are. There are applications not just to do what we call reverse engineering, where you digitize and create a CAD model, such as that fuselage, but you can see some of these color maps, and this is indicating the deviations, or what we refer to as quality control or quality inspection of these parts. If you have a CAD model, you can scan the parts and compare the scan data against the CAD model to determine if it's accurate. And that's a very common application. Another entire world for the 3D scanning that we get involved in, and many other people do as well, is the idea of buildings, facilities, and sites, otherwise known as AEC, or architectural engineering and construction world, which is a gigantic world. Think about it. There are millions of buildings out there, and almost all of them were designed pre-computer, or certainly not in the computer. And so if you want to renovate an existing building, and today architects like apparel designers work in the computer and almost exclusively in the computer for design work, they need, excuse me, they need that actual building in the computer in an as-built format. And so we go out and we scan, and I'm going to run this video while I talk. And this is an example of a scan that we did in a downtown environment, actually in Annapolis, Maryland, where we scanned roads and sites and facilities, as you can see. And this is known as what's called the point cloud. There are millions of 3D points that allow us to get a very dimensionally accurate view, in this case, and scene of these spaces. And this is what we do. And then we convert this into CAD information subsequently for architects if needed and when needed. And that the corollary application would be historic preservation. On the left, you're seeing the building scanned, and this is scan data with color, and it looks almost like a photograph, which is great. When we remove the color, which is easy, on the right, you see the geometry, and this can be done, again, extremely accurately, both from the laser scanners that we use as well as drones. Drone photography to get the roofs and all of the textures and color information, and resolve that using photogrammetry, which we will talk about shortly. All right, we go back, as you heard, many years to the mid-90s. This project, we were asked to get involved with by the U.S. government to demonstrate these capabilities right after 9/11, the tragedy in September of 9/11, where major buildings were destroyed, and the government wanted to see what these capabilities of scanning were all about. And they suggested Abe Lincoln at the Lincoln Memorial. What if the plane had hit the Lincoln Memorial? No more Abe. So we went down with very early technology in this space, and we scanned Abe Lincoln. And as you see here, some of the scan data, and on the lower left is a 3D print of Abe Lincoln that we produced in 2001 to demonstrate that the 3D model that 3D information could be used to reproduce Abe Lincoln should something happen. And that was successful, of course. Another application, subsequent, many things like this, very important things like the Liberty Bell in Philadelphia that we've scanned at fingerprint level data in the last few years, and have that preserved should something happen. Also, what's known as the Tomb of the Unknown in Arlington National Cemetery outside of Washington. And you can see that crack, and clearly something bad might happen one day. And so it's now digitally preserved, as you would imagine, and could be reproduced. This leads us into the wide world of art and sculpture and museums and artifacts, which we are very deep in and have worked with hundreds of museums around the world. This is one example using what we call structured light, very high accuracy scanning technology to capture, in this case, the sculpture and preserve that digitally. We've done thousands of projects like this in museums. And here's one more example, a Matisse piece, very famous Matisse piece up at the MoMA in New York. And we scanned those 4 very large pieces to demonstrate how they were designed by Matisse over many years, one by one. And you can see the colors on the lower right demonstrate that deviation or change from piece to piece to piece. And again, many different types of art and sculpture in many different museums. This you may or may not be familiar with. It's the artist Jeff Koons. We've done all of his, well, much of his work for years. And these are reproductions, right? These are productions, digitally fabricated pieces from scans that we created from small models. And these are all, some are stone and aluminum, and these are very, very high quality fabrications from digital data that we produced from the original models. I mentioned Smithsonian. We've done a tremendous amount of work at Smithsonian. In fact, helped create this original X3D website. We're noted there and have scanned many of those pieces that you see and have subsequently done many more. The Smithsonian has a very large scanning site that everyone should take a look at. I mean, if you think about it, how many people will ever get to a Smithsonian? And remember, many, many things are stored in the vaults and not available to the public. So why not scan things and bring it out? Another world that we get involved in that helps people very specifically is the idea of medical prosthetics. We have scanned lots of cases like this with many different hospitals, and we can scan and mirror and reproduce the opposite ear, for example, and ultimately recast that in a silicone, which looks extremely lifelike, and this can be worn and people look whole again. And we've since transitioned much of this capability over to many of the hospitals that we've worked with, and they can do this themselves. We're very proud of that. That gets us into the area of scanning people, or often for figurative sculpture, but also medical applications, and as we mentioned, VFX for movie production. And we will look at that. So here was one of our first movie applications, scanning of this actress many years ago for the movie Black Swan, with very primitive technology at the time that we've subsequently created significantly better, faster ways to do this, as you will see shortly. But other applications of scanning for movie production, if you think about it, they're going to film, and these people and their scenes and costumes are going to be in the movie. And then they're going to go off and do special effects that are all generated in the computer. And that has to be very, very accurate, lifelike, and exactly what they saw in the film, and with no deviation. So these things are scanned and digitally reproduced for the movie productions. Another one that's fun was the monkey for Night at the Museum, which we scanned for Night at the Museum 3. He's the same monkey in all 3 movies, which was a little trivia question. And again, prosthetics, right? So the idea of things that people wear in these movies that might make them look not so real, human-like. Also the props and vehicles and sets and locations that are using this technology. Very famous car from the movie Men in Black 3. This is probably an even more famous car, the original DeLorean from Back to the Future, that we then scanned for the movie Ready Player One. And it was used again in the special effects. Here's a location scene in New York City. And again, the scan is on the left as well as on the right. Without the color, you can get a sense of the geometry. And a very large prop, the Wonder Wheel in Coney Island in New York, that was also used in Men in Black that we scanned. And you can see a CAD model on the right that was created directly from that scan data. Others gets us into the idea of costumes and, in this case, apparel. So the idea of scanning Spider-Man and his costume, which is very tricky, into the computer. And we've done this many different times, many different costumes of this nature. We did a project a few years ago for this magazine and organization, and it was for this model, Carly Kloss, where we scanned her in multiple poses and multiple outfits. And it was to demonstrate the capability of 3D scanning as well as 3D printing and its potential impacts on the idea of models and photo shoots. So here's just an example of the camera rig and the captures that were taken. And on the right, the 3D spinning example of Carly in that particular example. We did a project with Parsons in New York several years ago that ultimately was used for a VR experience, a really very high-end VR experience. And this is a very famous historic dress that we scanned at extremely high levels. When you wore the headset and you put that on and you pulled up that dress, you literally thought it was in front of your face. It looked as if you could just absolutely reach out and touch it. And it was done at extremely high levels. And I think that's the point of scanning and why we need to scan for apparel, because the design process does everything it can in the computer to recreate reality. However, it isn't quite there yet in many cases to get the level of reality that you get from photo shoots, and this is why these are all still being done, to take the real piece with the real wrinkles and the real folds and the real creases and capture that and that level of reality for whatever downstream application it might be needed for. Other apparel applications, again, dressing these mannequins is an art, as everyone on this talk knows, and the idea of capturing that is very complicated, and it's very difficult. So doing that at very high levels to capture that level of reality is why scanning is employed. And the same can be true for the accessories, the bags, shoes, footwear, which we'll talk about. And we go into many other things. I mean, the idea of scanning can get into all kinds of things in the consumer product space. The idea of scanning it for e-commerce, for marketing, for promotion, all kinds of applications that are on the horizon for the use of this. And, you know, I shouldn't even mention it, don't want to even mention the concept of the metaverse. We don't know where that's going to go, of course. Here's an example we did with our friends at Ventana, where we captured, in this case, this beaded bag very accurately in 3D, and it was subsequently used to demonstrate some of these capabilities. Again, starting from the reality of the actual physical item, moving into 3D digital in a very accurate, very realistic way. Now, here's a quick commercial that was running that you can see, and we were involved in this project because of the footwear. All of those are done. This was basically a VFX shoot at a movie level, but it's for a commercial. And these footwear were captured, as you'll see, right here. So we scanned each of those footwear pieces and provided those at very high levels to our client for use in that VFX reel that you just saw. Now, this has led us to the creation of many different styles of capture systems, especially for human body and for instantaneous style capture. I used the term photogrammetry earlier. We heard the talk just a moment ago on footwear capture and others, and these are often using this concept of photogrammetry, which is camera-based. So we've done our share of development and use them on a regular basis. This is one more example. It's an art exhibit, an art piece exhibition in Columbus, Ohio. It's called As We Are. It is a giant, essentially photo booth that you go into the back. We built the entire pipeline and photo booth from beginning to end to allow the capture to be taken from the photo booth. And by the time you get up and walk around to the front, it is your face on the front of that piece in 14 feet tall, which is pretty, very, very cool. And it is, as I mentioned, an art exhibit. We've created another system that is a very, very rapid automated scanning system for small objects, including footwear and accessories and just any kind of industrial parts. We call it PASS, Part Automated Scanning System. And it can roll through parts and take scans every 2 minutes, completely automatically. You simply place the part on the turntable, and these many different styles of objects can be captured and are ultimately automatically processed into these 3D models with textures and colors and are dimensionally accurate sub-millimeter. And we're working on many different industrial as well as e-commerce applications for this new tool. Here's some examples in the apparel and accessory space that we've captured, again, all automatically rolled through quantities, collections of these types of items with this device. As I move on, here's an example of a bunch of shoes. I actually did this one myself a few months ago. We had ordered some new shoes. We placed them on the machine. I did this, and literally every 2 minutes I was scanning another pair of shoes. And we have a collection that's up on Sketchfab that if anybody wants to see is welcome to go see. All right, so this was a really good case study here that we did. The idea of scanning a footwear. Here's actually the example right here. And somebody earlier mentioned this in the talk previously about the idea of CT scanning. Now, you're not looking at the CT scanner here. You're looking at the scanner that gets the outside of the shoe and all of the high quality textures. And here we go with the footwear in a CT scanner. And this is in our lab. And we scanned the interior of this shoe and then superimposed the outside with the inside information. And you're seeing 3 different animated examples of how to display this information. They are all doing sort of different things, but there's many different ways to incorporate these two together. And we're very interested and are working closely with the OEM of that CT scanner to add this 3D photo texturing capability to the outside of the things that people might want to scan. As I move through, oops, don't want to skip over this. This is a different 3D sort of device that we created. It looks like it might be just doing simple 2D texture photography. What we are doing here is actually, we've created a device that moves light around and captures relatively flat, but yet 3D objects. Here's one example that I'm showing. And now you're seeing on the screen rolling around what actually is a flat image, very much a flat, planar 2D image with information texture maps that allow it to be shown with what are the textures, seemingly the textures, thicknesses, and shapes of the geometry of the objects. So you can actually study the threads, you can study the heights. It's dimensionally accurate, but yet it's an extremely lightweight, transportable, neutral format that you can share this information. Lastly, we've gotten involved in many different projects for the idea of scanning people. And one of the reasons that we do this is to help influence public policymakers on the awareness of this advanced technology and the importance of this as it relates to manufacturing and the industrial applications that we talked about. And that includes, by all means,
Hey, Michael, these are superb examples, and I think everyone's got a lot out of seeing the kind of the journey that you've been on with Direct Dimensions and how you've gotten through to Apparel. We're a little over time, and we've got a big panel discussion coming up behind you. So I'm gonna segue from you into the next folks. But thank you so much for showing us all of those and demonstrating how that journey moves along.